Okay, hello everyone, and welcome to this new video. We are today with Simon Sack, who is also known as the Tech Punk. He founded his company Neurologic in 2018, as he's here today with us to talk a little bit about his company and a few subjects about data science, generally speaking. As always, if you're joining us on live, you can directly ask your questions or try to interact with us, whether on YouTube or on LinkedIn. I will be here to take your questions to Simon if needed, and I will also be able to interact with you directly on the chat if you have some specific topic that you want to ask us. I myself am Alban Tuet, responsible for the MLOps course here at Data Scientist, and I'm also a teacher in Data Scientist. I'm pleased to let the lead now to Simon so that he will be able to introduce himself and start his presentation. Thank you.
Yeah, thank you very much, Alban. Well, I think I can share my screen. So then everyone can see my screen. So now I think you can see it.
I don't think that we can see it right now.
Okay. So my system said,
okay, this is it.
Oh, nice. Yeah, well, let's start. Welcome, everybody. Let me introduce myself. Hi, I'm Simon. I'm 28 years old, and I studied computer science. I started in 2015 in Siegen, Germany. I founded Neurologic during my studies in 2018. I won an award in 2022, and this year, I was promoted to LinkedIn Top Voice for AI, and also I'm regional lead for Western Germany in the German AI Association. So today we'd like to talk about a few topics. So this presentation is not to give you methods of data science in a deep brief. It's not a mathematical or a statistic lecture. Today it's more to give you an overview how to implement really artificial intelligence, machine learning, and SMEs or corporates. So more in a strategic view. So let's start with an overview of the current situation, then step over to how to start to implement AI in SMEs or corporates. I will show you best practices and more. And after that, I would like to, take a look beyond the AI Act. I think it's very important to look at it because I think everyone who is working in the field and would like to work in this field has to handle with it. And I think for everyone, the situation is clear. So I will skip 30 pages about disruption, Moore's law, DeepL, cat pictures, and so on. And I think everyone knows that there are more smartphones than toothbrushes. So let's take another look on it. So we have to remind that technology is exponential, but we humans, are thinking linear. So let's think about exponential systems. So like the climate change or crash at Wall Street or something like that in 2008, 2019, or I think, everyone is the situation of COVID-19 very present. And every exponential system starts with the Gutenberg moment every year. So Gutenberg thinks about how to scale knowledge of books or something like that, and he develops this printing machine. And for example, the complete use of the internet was changed, for example, by Google. Or if you think about when Steve Jobs launched the iPhone and so on. So every exponential system starts with a Gutenberg moment. And from that now on, and especially from 2022, AI's Gutenberg moment was ChatGPT. And from that on, science fiction becomes science fact. If you think about AI, you can think about self-driving vehicles, like these vision systems in a car that recognize people or other cars or traffic signs. You can think about a smart concierge in a hotel, or you can think, for example, applications in the medicine field. And if you ask SMEs or corporates, what are you thinking right now about AI? You see different opinions. For example, if you ask them, what is artificial intelligence? You get different answers. A few of them say, okay, AI, it's the ability of device and software to think logically, to learn, to solve problems, to understand language, or to store large amounts of data. And others say, okay, they monitor individuals, they play games, or sometimes they want to control the human mind or to take over world domination. So you have a side which have a very good look on it, a good view on it, and then you have an other side which thinks, okay, the Terminator comes. And this is what you have to handle with if you talk to SMEs or corporates, and if you want to help them to get a strategy. And it's very important that you are able to show them, okay, what is the difference between human and artificial intelligence in the first step? So, and if we look at definitions, you saw, okay, artificial intelligence is often understood as a simulation of human thinking and action. But there are two definition problems. First, what is intelligent human thinking and action? It's not defined. And you have another definition problem, that humans are always used as a benchmark for intelligence. No one knows if there is any species which is more intelligent. And then you see manifestations of intelligence, like linguistic intelligence, musical intelligence, logical, mathematical intelligence, spatial intelligence, and so on. And you see that the terms always, or always the quote illustrate that you have boundaries and of what is possible, and that they have to constantly being redefined. And then you can see in all that there are three types of evaluation can be used, combined, or isolated from that term. So first, description, the description of what is the current state, what you see, for example, and prediction, what is the future state, and prescription, for example, what do you see in a scene or something like that. And then often, very, very often, you hear that artificial intelligence is a new development. Because of the release of ChatGPT, I think for many people, AI was such a research thing and sounds very, very prominent. And after that, then if you ask managers or something like that, they will say it. And then you have to say, no, it's very old, because it's a development which goes back in the 50s or 60s. And then you have to think about that AI is a collective term for a lot of different technologies. For example, statistical machine learning, neural networks, deep learning, rule-based expert systems, NLP, natural language processing, and also physical robots, or something like software robots, robotic process automation, all part of the term AI. Here, for example, you see the paper of Alan Turing, where he used AI in the 50s or 60s, the term. And then you see what's going on in Europe, for example, or worldwide, which are the most valuable AI companies. Then you see a lot of maybe China, USA, and then you can ask yourself, oh, what's going on Europe? And on the other side, you see that the market size of artificial intelligence is growing, and it's growing very fast at the moment. And then you see that, so from 2027 to 2028, the exponential growth is very, very increasing. And yeah, I think then the party starts extremely. And in the end, so you know a lot about, I think, the technique and the technologies after that. But you have to think always, if you talk to SMEs or corporates, that they have a different view on this topic, because they were influenced from different parts. First, science, okay? There are research projects and so on. And then they see applications in practice. So, for example, a smart sensor, a smart software piece. They use Netflix, they use recommendations engine, for example, or they use their phone with different machine learning or deep learning models. And then there is a part of fiction from movies. For example, Terminator, iRobot, and you have to put all these different views on, and you have to say what is real and what is unreal, what is fiction, what is really science. And then if you have this view, and you will give this view to your for the people who are interested in this field, then you see you have different innovation driver in an SME or corporate. First, you have the C-level. They have a strategic perspective on this topic. So, and where often the topics really are very interesting are in the operational level, because they have problems in the production, they have problems in their processes, and they want a solution for that. And there often is a clash between the strategic perspective and the operational level, because if you only build different smart solutions for the operational level, they might, or it's possible they might solve the whole problem from a strategic perspective. So it's very important to get a vision for AI in a company, and then from that on, you find solutions for the operational level. And then you see a lot of trends in 2024. For example, they are different things, intelligent applications, for example. Then you see different platforms, for example, like ChatGPT. You see industrial cloud platforms. And then you see a new trend. After ChatGPT, DALL-E, Google AI, Midjourney, and so on were released, there were a very funny meme that describes the whole situation at the moment. You see, the fastest thing on Earth is the cheetah, the airplane, speed of light, and then people becoming experts in AI. And there's a clash between, because you have to differentiate between a really expert or a user. If you use only, for example, Midjourney, ChatGPT, or something like that, you see that it's not that you are a user of a software, but you don't think about data architecture and so on. And if you then look on the whole term, you see that there are a lot of subterms like machine learning, deep learning, or GANs, where ChatGPT is located. And if you think about implementing AI really in processes, you have to think about that behind every artificial intelligence is human intelligence, lots of planning and controlled conditions. And the main point is that you have to transfer to your potential customers or in your company that artificial intelligence is not the same as human intelligence, because you build a model, for example, then you train it, and during this training, the mathematically knowledge is derived through algorithms. So, and then use the inference. So in a nutshell, you use data, build the model, and then you use the model for the inference. And that's not the way how humans learn. So humans have the inference and are learning through feelings and on the way. And if we look at the whole history of AI, you see that the potential of AI is increasing by computer power. So first you start with, first in the 70s with logical thinking, for example, this chess computer. Then from the 2000s, you see learning and predictions are possible. For example, first self-driving cars, or also Alexa. And from the 20s, you are able to learn, predict, and generalize information because you use new methods. And with that, you can ask what's happening next? What's happening in the 30s? Maybe critical thinking, creativity. And you have to think about, is singularity possible? But the answer is, it's always difficult because the future is always in motion, and we human tend to overestimate the effect of a technology in the short run and underestimate the effect in the long run. So you see, it's a philosophical answer, but you can't give the right answer to that because it's a big thing. You have a lot of different influences. Yeah, then I don't want to talk about ChatGPT or a top OpenAI use cases because I think it's very boring. Yeah, you have to think about why, for example, these showcases are so impressive for all the corporates. And they saw a lot of these use cases, and then they think, okay, this is so interesting. So I'd like to build something like that or something other in my company. Then you have a clash, because if you show them this in real life, the situations are completely different. We have models which are working, and then if the situation or the context change, the models collapse. And that's the main thing in our work, that 2% of an idea to start with AI, it's nice, but 98% is the execution. And now I'd like to start that I would like to show you how to start and best practices and more to start to implement AI in your organization, or if you have ideas to work for customer, how to start best. And if you'd like to start, in a nutshell, 3 prerequisites are necessary. First, you have to set a goal. You have to set a goal on a strategic perspective to solve your problem. Then you need orientation. So is the problem complex, or is it well known? Is it easy to handle? And then you have to start in the end. And some projects, yeah, don't start because they use too much time to set a goal or orientation and often forget that. So really start if you want to solve a problem. First, you have to set a goal. What's your problem now? So what's your problem now? Really, would you like to only implement AI, or do you have a a problem, for example, in your production? So the quality is bad, or the efficiency of your production is not good. So define your problem now. Then think about what would be my definition of awesome. What would be the best outcome for my company, for myself? So, for example, would you like to increase your quality? Would you like to reduce costs? Would you like to decrease maybe the production time or something like that? And after that, you have to set your next target conditions. And then plan your first steps. And then it's very important to analyze your problems. So for that, we often use the Stacy matrix. So you can see on the x-axis, for example, how to use a problem. So is there a common technology, or is there a complete new technology? On the y-axis, you see what's the requirement. For example, is it well known, or is it unknown? And if you have an unknown requirement and you don't know which technology you should use, it's a chaotic problem. You don't know or you can't describe really the problem. It's very chaotic, and for that you need a whole new solution. So it's more research and development, for example. And you can think, if you are here, the problem is, or the solution would be very, very expensive. And if you think you have, for example, you would like to store data, and you would like to customer data, and you would like to maybe get churn prediction or something like that, then it's a easy to complex a problem, because there are solutions on the market like HubSpot or something like that, and then it's the best solution. So, and on the fourth step, you have to think about all your problems. Then you have to think about use cases, and then you have to analyze all these use cases. And the best way is to start with the use cases in this quarter, because they are easy and handleable. And if they are chaotic, you need a lot of money and a lot of resources and manpower to solve these problems. And then it's very important, please walk and don't run. It's very important to set small goals, achieve these goals, and explore and iterate through small sprints. It's to motivate your team and yourself, because if you want to set or achieve this goal here and you start here, it could be very frustrating. And then you have to really think about, what can AI achieve for my problem? So, and you have to think about narrow AI to solve a specific problem, and well-defined application problems. And then you have to think about general AI. So creating technical solutions that approach or exceed human intelligence, or something like that. And forget it. It's a joke. So you have really to think that you are able to, or to think that the best use cases are really use cases that you can really define. You know all or nearly all the problems, and there is no general AI which solves all your problems. You need to you need to create small applications or small models for specific problems that you like to achieve, and with that you can solve bigger problems. And then you should ask yourself, why do I want to undertake an AI project? And for that, my opinion is that it's very important, profit over coolness, because you don't earn money with a fancy marketing use case. Maybe customers will come and say, oh, really cool, I want this Terminator with the sun classes, but in the end you can't deliver the Terminator with the sun classes. So think really about with what problem is able to achieve bigger goals for you. And on the other side, do you really need AI for this solution? And this is the next question you have to think about. Is AI the right solution for me? For example, you can think about this use case. So last year, a customer asked Neurologic and with the use case. So I have a problem. Here are two different things, one red, one green thing. I want to classify this two objects. Are you able to build an AI application for us? So, and we say, yeah, we can build an AI application for you, but it's more cheap and makes more sense to build a computer vision solutions, and the solutions you need round about 30 lines of code, because you analyze the pixel and then you have the solution. So the first, if you want to train a neural net, you need around 30,000 euros. And if you use this computer vision algorithm, you need 2,000 euros with the hardware and so on. And with that idea, I would like to show you, really think about, is AI useful, and is this the right solution for this for this use case? And then you have to think about who should execute the project. The project team is so important. So you have to think about internal and external the internal and external team. So you need to have internal domain experts who are capable and who are in the topic. So without these domain experts, it's very, very hard and to solve the problem, because an external team isn't so deep in the processes and are often software, hardware guys, which, for example, have no idea about deep, brief manufacturing processes. And after that, and that's always the point, what data do I have? So, and we often see that if we get such small tables, that there isn't so that fundament of data, and then you have to create strategies how to store data, how to generate data in the end. And after that, if you have enough data, or your customer, you have to start the process that you take a deep look on the data. And I think everyone knows that real data often pose problems. So you have to clean the data. And after that, you clean the data, you have to think about now which approach is the right one to solve the problem. And if you can answer this question in connection with the use case and the strategy, you can start with AI. But often you will see that in the first step, before you have the data and so on, you have to think about automation. And that's one thing I often recognize in chats or in calls with potential customers and or other guys from the industry, that there is a gap and a lack of knowledge between what is automation and what is AI. And it's really simple and clear. Automation is process driven and AI is data driven. So, but you are able to combine, and it's very, very nice to combine both technologies, for example, to create workflow pipelines where you use a machine learning model to get a value, for example, from an email. Then you use another machine learning maybe to flag a priority, and then you start a workflow. So, for example, if the flag is 0, start workflow 1, and if the flag is 1, start workflow 2. Now I would like to show you 3 use cases from our side. So in 2021, a green space manager wanted to know whether it was possible to remotely diagnose these areas. So they produce robots, which are mowers, and they want to know, is there a good field of grass or is it bad grass? And he asked us, so where can we start, because we have no data. So and with this customer we generate a sensor box. This sensor box was connected to a robot, and then the robot starts to collect a lot of data. I think the data collection was from the end of March to August. And then we built an application like Tinder, you swipe right or left, to build a classifier if the grass is good or not good. And with that, we generate a model which is able to show if it's good or bad grass. And you can see here on this visualization of a field which shows if there is a green flag, it's good grass, and if there's a red flag, you have bad grass. And with that, the customer wants to build a new business model, because they like to rent these or lease these mowers, and like to sell fertilizer for the fields. Then we have another use case. Machine manufacturer for laboratory equipment would like to replace his old products, which he was previously worked with classic image recognition, which an AI supported process. And the question was, how can a function system could be replaced with the AI during normal operation? And here you can see a picture. This picture shows you different classes of cells. Okay, you can see green cells, they are living cells, and red cells, they are death cells. And with this customer, we set up an AI model. It's a neural net, which is able to classify the dead and living cells. And what we have done is that we create testing firstly the data sets. After that, we show that the quality is okay, but not the best. After that, we started the requirements engineering. Then we designed side by side with our customer the hardware and software system. And then we generate new data, test the new data. And after this iterative process, we built a demonstrator application. And the third use case is that the machine manufacturer requires an optical and data supported solution for detecting offset and reparameterizing the calibration of a machine heads. And he'd like to know, and he would like to know the question, how can a standardized procedure to be developed in which precise calibration is possible before each process starts? And what we have done is testing the existing procedure. After that, we start requirements engineering, redesigned the whole architecture, and from that on, we are generating a new data set for the optical identification, test the data. And after that, we started rapid prototype application and generate a system which allows to reparameterizing the calibration of the machine head. And then in case 4, and it's the last case before we jump over to the European AI Act, is that an operator of a large industrial plant for coatings wants to optimize its use of the materials in real time. And he asked us, how can AI be used as a real-time application in industrial processes? And this is one of the biggest projects we are in at the moment. And what we have done and what we are doing at the moment is firstly define the whole core functionality. After that, before thinking about AI, we had to build a software prototype to quickly gain experience, where we collect data and where we are building a process that we are able to really operate in real time, because we have to influence the whole production line. And then after that, we set up the suitable hardware infrastructure. We have to jump from proof of concept to proof of concept, generate and test data on an ongoing basis, and build different kind of models as agents which are communicate in their own network. And with that, we are able to use real-time data to influence in real time the whole production system. And the benefit is that customers don't proceed or don't manufacturing bad things and so on. So I have talked about use cases and what we have done in the past. And I think one of the most important things at the moment is that you have to think about the European AI Act and what perspectives does it enable and what concern does it raise? Because it doesn't matter which application in Europe and in which application is included AI, you have to classify it and you have to document it of the 4 types of risk in the European AI Act. But first, what is the European AI Act? The European AI Act handles the way how the machine and the human interacts in a nutshell. So, and this is done with 4 types of risks in the Human AI Act. So in the European AI Act, you see 4 different classes. For example, the unacceptable class, so it's prohibited, like manipulation, social scoring, or biometrics. Then you see a high risk in the European AI Act. So, and for that you need conformity rule. For example, education, employment, immigration, and law. So to think about, if you use ChatGPT for education in the way of the European AI Act, you have to set up a conformity rule. And then you see limited risk. For example, chatbots, emotion recognition, and deep fakes. For that, you need a transparency rule. And deep fakes, you can think, okay, it's manipulation and it's unacceptable, so it has to be prohibited. And if you think that way, you are right. But you can also think about deepfakes if you use it, for example, for platforms that avatar give you information about a product or something like that. It's more in, or you use it in another not in a manipulate way. So it's a different view on it, and there you can see how, or the way you classify your model or your system. It's very, very difficult in some ways. And then there is a minimal risk, for example, spam filters, video games. For that, you need only a code of conduct. And then this meme, I think it was very popular in December last year. You see the leadership of key technologies, and you see, okay, China is leading in 5G, USA is leading in, for example, internet platforms. Both are contested in next generation networks, semiconductors, and then you see Europe is leading in regulation. And let's think about that. The European AI Act. What are the advantages? For the first thing you get with the AI Act, the advantage that you have a legal certainty. You are getting trustworthiness of your model. Okay, you can really you can really get the trust in the model, and that okay, if this model say, okay, for example, yes, you are allowed to go over the street, that you are allowed, and that there is no risk. And you get a risk-based regulation. And on the other side, you increase your competitiveness, because I think in the EU, it's like the German TÜV sign on your model, and also it protects the citizens because of the democratic basis. But you now can ask yourself, what are the disadvantages of the European AI Act? Yeah, and the first thing is the bureaucracy and the costs. And maybe you can think about insufficient flexibility. You can also think in the worldwide competitive, that it's not so good for that. You see that there are a lot of enforcement problems. And if you think, what challenges do companies handle with and face, is that you see a lot of the things, like the costs are really, really increasing, because if you think you invest, I think, for example, 200,000 euros in a project, you have to also invest in all the risk classification, and also the requirements are increasing. And it's a ongoing flow that you have a lot of adjustments. But in the end, I think if we do it right, it will have a lot of advantages, because we are supporting all our values of the EU, and also the living, or the living between the technology and human. Yeah, and last but not least, if you have any questions, you can ask myself. And this was a quick overview how to implement AI in SMEs and corporates. And if you want, you can follow me on LinkedIn. There is a lot of content every day about new trends. And thank you for your attention.
Thank you very much, Simon. So this presentation was very interesting. I I hope you enjoyed it. If you want to ask any question, you can ask them whether on LinkedIn or on YouTube. I would personally have a few things to ask you, Simon, if you want. Is so in the SMEs especially, what are maybe the the power of AI that can be the most useful in order to maybe optimize or accelerate the development of the those types of companies.
Yeah, I think in one thing is the product development and also quality assurance processes, because there are a lot of human power needed. And if you have a smart software system, it will, yeah, really increase the power and yeah, of such companies.
Hmm. Okay, and like what we are seeing right now, also with data scientists, is that a lot of companies do want to start building their own AI or to implement a machine learning algorithm in their own structure. But they sometimes face some trouble, some issue with the implementation of that, and they can see that it's not as easy as it seems at a first sight. What kind of advice could you give to those people who can be interested in that?
Yeah, I think you should first start with small proof of concepts. So you have to, there are a lot of tutorials you can use. And for these proof of concepts and prototypes, Python is really useful. But if you want to put a proof of concept or a prototype in a productive environment, you have to think about architecture and also the runtime environment, because for that Python is not the first yeah, the first idea, because it's too slow, and you really have to do a very good requirements engineering in the first or firstly, because if you don't, yeah, take a look on all requirements, you have a lot of problems in the yeah, in the future. And if you really um, if you really would like to build great applications, you can yeah, contact with partners, or maybe, for example, associations like the German AI Association. There are a lot of experts from different yeah, from different AI fields, and I think you should talk with them, and they will help you.
Mhm. Yeah, I agree with that. Well, my personal advice would be also, in addition to um, try to see if you can make something useful out of something that is not perfect yet. Uh, AI is something on the long term that you cannot build in a small amount of time, and so the if your objective is to be able to replace your whole organization with AI or shows process with AI, you may have to think first about how to replace part of it or to make the use of AI embrace a little bit more the company. The perfect example I believe is when you have, for example, in a company, people who actually use a specific tool that is not AI driven, and you want to help them use AI. You should first build an algorithm that would help them make the decision instead of an algorithm that will make the decision in the end, so that it's a small step to this final objective. We have also a question on YouTube that I'm going. Oh, I think I'm not allowed to show it directly, but maybe you can see it here. Yeah, thank you. Hi, Simon. Thank you for the talk. which language do you advise best for runtime? So I think it's talking about programming language here.
Yeah, yeah, I think so. So I think in the end, it depends on the use case. So for example, we have applications where we used a real-time engine from Java. And if it's more on a hardware side, we use, for example, C++. So it's more difficult than Python, but in the end, it's a really game changer in loading times and execution times.
Great, thank you. We'll also have a question of well Sedoso. How to scale an AI solution? I mean, how to fix a good price and justify as far as this technology is new and can blur the client with why you settle this price. So it's a bit technical here. Uh,
Yeah. So let me think about that shortly.
so I think there are multiple questions inside this
Yeah,
uh,
yeah.
question here. Um, so I think the question is how to justify that the price of your company was more when you use AI, and how to make sure that you settle the good price in front of your client there.
So in the end, it's the answer is also requirements engineering. You have to slice down the process with your customer in small steps. So start, for example, with a workshop. After the workshop, you start, for example, the workshop is for use case exploration. But in the first step, you have to understand, so in which status is your customer. So does the customer needs, for example, first an AI enablement, or is he also in this topic, or which customers do you're talking? Are they experts from the field? Do they only need, for example, technological advice? So then you start with a workshop, for example, requirements engineering. Then after that, you have the clear requirements. Start with the proof of concept. After you, or the goal of the proof of concept is that you show, okay, the solution works. So, and maybe for a proof of concept, I don't know, you need a smart budget from, it depends it depends on the use case, but you can think, okay, for that I need 10 days, then I need this hardware, maybe, and so on. Then you can calculate a price. After that, you have to define, or you have to presentate all the learnings from the proof of concept. Then you can think about, okay, what I need for prototype or an MVP. And what I'd like to show you is, don't think, okay, I have to build the solution and it has to be finished tomorrow. Think about small steps and use these small steps to achieve goals for your customer. You create and generate a lot of knowledge for your customer, and then you can think about the scalability of the solution and all the other questions do you have, because it's a process. And AI isn't like the internet. You buy a modem or a router or something like that, and you plug it in, and all things are working. It's a process. It's a change in the organization from a strategic and operational view.
Thank you. If there are other questions, feel free to send them now. Otherwise, I think that we're going to end the session right now. This meeting has been recorded and will be available on YouTube if you want to see it again some point. I hope you enjoyed it. Thank you again, Simon, for your presentation and your presence today. We'll see us again maybe in another webinar, and I wish you a very good day.
Thank you. Bye bye.